In this video, I'm going to confirm or refute some assumptions about the capacity of some of my components. So far, with my white LEDs, I've been assuming that they have an optimal voltage of 3 volts when we have 20 milliamps supplied through them. I also want to confirm that the Arduino board supplies a maximum of 5 volts from each of these points here, each of these sockets, and also no more than 40 milliamps from each of these sockets too. Now there's a good chance that maybe I'm wrong about the assumed voltage for my LED light, because when I bought these lights they did not specify the voltage. So what really is it? Is it 3 volts or something else? Now to make all these assessments, I'll need to do measurements and calculations. Measurements shall be done with a multimeter and calculations with a calculator. Firstly, to measure the current, you need to insert your multimeter into the circuit where it can measure in series. So I could put my multimeter point somewhere between here and here, or between here and here, or between the LED light and the resistor, or the resistor to that point there, or that point to there. It doesn't matter, because in a series circuit the current everywhere is the same. So to measure current, I'm going to turn the dial here to the current range, indicated by A for amps, and because the Arduino board is designed to emit a maximum of 40 milliamps, I won't use this range here, 20 milliamps or 2000 microamps. I'll use the 200 milliamp range. So there we are, and of course it shows 0 to begin with. Now going back to the breadboard, my blue wire was attached over here, this end here was attached over here. So now I've disconnected it and attached the using an alligator clip, the end of the blue wire here to the multimeter, and the black cord is now going to be connected to this part over here of the LED. So now the LED is on, and the measurement I get is 16 thereabouts milliamps. So that's the draw by the LED lamp, and that current 16 milliamps is the same everywhere in a series circuit. When working out the voltage going across the component, we do not insert the ends of the multimeter leads in series across the component. No, we must have the two ends of the multimeter leads, the red and black end, inserted around the component in parallel. So what does that mean? Let's zoom into the component we're interested in, which is the LED light. So that means using my black lead here as my pointer, I'm going to have one lead, the red one over here, and the black one touching this side over here. That way we're measuring the voltage drop across the LED. It has to be in parallel when measuring voltage. As we can see, I've now attached the two ends of my multimeter leads to either side of the LED light. The light is of course powered. So going to my multimeter, I've now set the multimeter to measure voltage, and I set it to the range of 20 volts maximum. And looking at the screen, it shows that my LED is using, at the moment, at this current of 16.1 or 16 milliamps, is using 3 volts. And still using the voltmeter function on the multimeter, I've rewired my measuring leads, the red and the black. So now my red end, positive end, is measuring the positive output from the Arduino board, and instead now my negative end is bypassing all these components here, the resistor and the LED, to measure the return to the Arduino board. So I'll put it over here, there, alright? So it basically bypasses the main components and There might be a bit of voltage losses along the red lead there and the blue one there, but it's minimal. So virtually all the voltage is used by the components. Let's go and see what is the voltage produced by the Arduino board. So there it is, about 4.62, 4.63 volts used by the breadboard between those 2 points. Maybe a little bit more for the blue and red wire I mentioned just a moment ago. So let's say the Arduino board is indeed producing about 5 volts or 4.7 volts, maybe thereabouts. And double checking the voltage drop across the resistor, I've got my two ends of the measuring leads from the multimeter. Going to the screen over here, we got 1.63 volts used up by the resistor. And double checking the resistance of the resistor, I've now set the multimeter to measure resistance. I've set it to the 200 ohm maximum reading scale, and we get 99.5 ohms, or basically 100 ohms. So it's basically within 1% tolerance of the ideal value of the resistor, which is 100 ohms.